Okay, viewers, in the previous examples, we were discussing this thing that how to check that the relation of the perpendicular lines is not transitive. See, for this purpose, we take L1 comma L2 in the relation and L2 comma L3 in the relation. So as L1 comma L2 is in the relation, so it means that L1 is perpendicular to L2, and L2 comma L3 is in the relation. It means that L2 is perpendicular to L3. So from this we cannot say that L1 is perpendicular on L3 because you see this diagram, okay, it will give you better understanding that here you have L1 and here you have L2 and here you have L3. So clearly L2 is perpendicular on L1 and L2 is perpendicular on L3, but L1 is not perpendicular on L3. Okay, so that is why we can say that this relation is not a transitive relation. I hope you people have understood it completely, that why we are saying that this relation is not a transitive relation, because L1 and L3, these two lines, they are not perpendicular. Okay, they are parallel. Now we next start a new topics which is called equivalence relation. A relation are defined on a set A is called an equivalence relation if it is number one reflexive, number two symmetric, number three transitive. So if a relation satisfies all these three properties, then we say that relation R, it is an equivalence relation. Okay, and if any relation it does not satisfy any of these three properties, then we say that a relation is not an equivalence relation. Okay, so we see some examples of equivalence relation. Okay, so the question is this, that consider the set T of all triangles in a plane. Define a relation R on T by, we say that any two triangles, they are in a relation if T1 is concurrent to T2. Okay, this symbol is used for concurrence. Okay, prove that this relation prove that this relation is an equivalence relation. So it is very easy to show that this relation is an equivalence relation solution. So first of all, we check that is this relation reflexive or not. See, we know from our class 9th and 10th that every triangle is concurrent to itself. That means that if you take any T1 triangle, then it is congruent to T1 and it holds true for all T1 which are the members of set T. Okay, so elements of the same pair they belongs to R, okay, and it holds true for all T1 belonging to T. It implies that this relation is this relation is reflexive. So the congruency is a reflexive relation. Okay. Now next we check that is this relation symmetric or not symmetric. Let T1 comma T2 it is the member of the relation. Okay. So from this it means that T1 is congruent to T2, or you can say that T2 is congruent to T1. Okay, as T2 is congruent to T1, it means that T2 comma T1 it is the member of the relation. So this relation is symmetric. Okay. Next, we want to talk about the transitive relation. Transitive relation. Okay. Let T1 comma T2 it is the member of the relation, and T2 comma T3 it is also the member of the relation. Okay. Now here as T1 comma T2 is the member of the relation, it means that T1 is congruent to T2 and T2 is congruent to T3. Okay. So it implies that T1 is congruent to T3. Okay. So as T1 is congruent to T3, so we can say that T1 comma T3 it is the member of the relation. So this relation is transitive. So you see that in this example, this relation is reflexive, symmetric, and transitive. Hence, we can say that this relation is an equivalence relation. Okay? This relation is an equivalence relation. Thank you very much, viewers, for watching this video. More examples of the equivalence relation will be covered in the next